Good morning, C. Grover. All right. Welcome. Morning. Happy Saturday. For anyone that is new, my name is Tim. I go by Foamy Guy on GitHub and Discord. And I usually stream at this time each week, working on stuff related to CircuitPython. If you don't know what that is, you can learn more at circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. And the way it typically works with CircuitPython, you plug it into your computer with a USB cable. It shows up like a thumb drive, and then you can edit some Python code on the drive. And when you save it, the microcontroller will execute the Python code for you. And you can interface with all sorts of other electronics and things. CircuitPython is an open source project. Anyone is allowed to use it. Anyone is allowed to put it in your own product. You can make your own device and add support to CircuitPython for it. You can sell it. You can put it inside of whatever you want. All of it is made possible by Adafruit. This is their website, adafruit.com. They pay a team of folks to work on the CircuitPython project, including myself. So thank you to them for doing that. And if you would like to help support CircuitPython and all of the other open source software development that they do, one of the easiest ways to do so is purchase hardware from them at their website, again, which is adafruit.com. Today, I am jumping into a new revision of this combination driver. So last week I was working on the SPI driver for this BMP5X. And I did over the week, last week on this stream, I was working on the SPI driver. And then over this past week, over the actual work week, I did get it further. And I have a version that does both SPI and I2C. I had some PRs in to register SPI and BMP5X. And I had a chance to chat with Scott a little bit yesterday. Yeah, that was yesterday. About how, in his mind, it makes sense to do this. And so I have a good idea of what to sort of move towards, which is a new layer inside of register. So let me open up a few things. Let's get the Python version of register. These are MPY files, which means we can't see inside of them. Back the side of the IDE there. Hopefully get this to refresh, maybe. No? Okay. Interesting. Huh. Oh, I didn't do upgrade, I think, right? Ready to install, but it's already installed. Gotta read the message. There we go. Okay, there we go. It's gonna refresh. I know it's gonna refresh because it's frozen and I can't do anything else, which is a neat quirk of this IDE. Well, I think it's honestly the way my project is structured. I need to probably rethink how the main project here is. It has a lot of stuff in it at this point, and I think every time it's like finding these changes, it's trying to go back through and index a bunch of stuff that it really shouldn't, which is on me to change that up. I'm not going to do it now. I am going to wait for it to let me do anything. There we go. So right now, inside of register, we have all these classes like RWBit, RWBits, ROBit. What is up, Johnny? Nice to see you, my friend. And the way these work is you set them up with like which register they point at, and then which bits they point at, or a single bit if it's only one. A couple of other things like how wide is the register? Is it the least significant bit first or last? And then these are descriptor classes, which means they use these get and set things. And essentially, right now, these classes, this RWBit class, knows and does the work of reading out of the register by writing and reading on the SPI device. So object gets passed in. Object has an I2C device property or field or whatever. And then we are writing and reading on that field. And all of this happens inside of here. And so this one knows how to handle single bits. It knows how to update single bits over the I2C bus. This one, of course, is multiple bits with plural S there. So it knows how to read and write multiple bits over the I2C bus by writing and reading, again, on that I2C device. And then the new ones, which I had made for the SPI driver, essentially were the same. They were the same type of object. They even have the same name so that they're a drop-in replacement. They have to be set up a little bit differently. Well, okay, so they don't really have to be set up differently, but they do expect a differently named property. So the I2C ones are looking for I2C device. These ones are looking for SPI device. But generally speaking, their role is the same. They're aware of how to communicate and get data out of those SPI registers. They are, in this case, they're responsible for shifting that first bit, which is one of the things we worked through last week. They're responsible for shifting it to either 1 or 0 based on reading or writing, and then they go and do basically the same thing the I2C one did, which is write on the bus and then read on the bus in order to do all the stuff they need to do. What we want to do, though, is change this up a bit to where we are going to have a new thing in here, which is like register accessor pending thinking of a better name. But for right now, I don't have a better idea. So we are just going to use that name. And then the goal is going to be to shift shift the work of reading and writing out of RW bits and into here. And this is going to provide like a read. So so this is going to take the bus, I think. Yeah, this is going to take the bus. And it's going to have a read register, which is probably going to take like not get too far into what everything it needs for sure, but it's basically going to be the same things that we're writing and reading in here. So it's going to have the bus, so you're going to have to give it the address for sure. Realistically, I assume it needs the rest of all of this stuff too. Like basically, I think it needs... So num bits, maybe not, but it would need the register address, it would need the lowest bit, it would need the width, it would need that signed. Signed complement. So I think that's if it's a number and it can hold negatives using that mechanism. But the goal is to get it to where this get function is basically, instead of all of this stuff here, it is going to not be looking for I2C device. Instead, it's going to be looking for object.register_accessor, and then it's just going to be like accessor.write, accessor.read. And the rest of the complexity will be inside of there. And let me read this bit again. So make this more flexible, picturing BMP class that takes in the bus and adapts it internally to the transport. I think a register accessor that reads and writes registers. Data descriptors will not be from that. We'll instead look for this on the object. To reference, yeah, this was helpful as well. I can read through this a bit more too. Let me look for one more thing real quick, actually. Actually, I need to do this. I don't know what's going to be BRB. I don't know what's going to be the editor when I open it. Okay, yeah, it was fine, but just in case. The one thing, actually, I don't know if I asked about or got a clear indication of was, are there two different register accessors? Or just one? I think there should be two. I think there should be SPI register accessor and then I2C register accessor. And then theoretically, you could make more of these as well. So UART is sort of in the further away distance plan after SPI and I2C are working. But Scott's got some pretty cool ideas as well for other different transports to use. Some of this will be thinking through stuff. Need to figure out where the delineation is exactly, because this is going to basically the goal is to end up with only one version of RW bit and RW bits, not having a SPI one and an I2C one, and then the driver has to pick the right one and use it, but instead having a single version of these. And because they rely on the accessor, and the accessor has a common interface that works with both, that abstracts away the details, it then means that these classes get more flexible. They could be used with any kind of transport layer since they don't know the details of all of this stuff. So I'm almost tempted to start. I think I'm actually tempted to start in SPI land. Because that's what I worked with most recently and have more experience with overall at this point. So, thing to think about though is register accessor for SPI is going to be the thing that knows about all of the first bit, this stuff, right? So this is definitely going to move. But then where this gets called right before we... Why is that? Why didn't it usually it just goes to 1, I thought. Interesting. This gets called right before we write, so we're going to end up having this... And inside there... So in this case, we are reading the full register and then getting out the 1 bit we care about. So we basically want to be able to... one question is, do we want to still use this buffer? We basically want to be able to give it an address and get back a byte, but I guess we need to give it more than... Well, we need to give it more than the address. We would need to give it we need to give it the address, we would need to give it the length. I think it probably makes the most sense to just go ahead and give it the buffer as well. So another thing that we can start, I think, is I want to make a here we go. We're going to do register bit. We're going to do register bits. Oh. What? Good morning from a hazy Toronto. What is up, Gordy G? Good morning to you as well. Might as well take that goes bit. Let's copy the whole. Not gonna have this. The rest of all of this is the same. So here, instead of this, we're gonna go... Why this object as SPI? It's not clear to me why this does this instead of just object.spydevice.write. Oh, because it's going to close it, I guess. So I don't think the accessor will close. The accessor will just be, I think, a function. I think we skip the with and we just go object dot register accessor. And we are trying to read the register, so we're going to go read register. We're going to give it the things that it needs so far, which are address. Don't have. Why don't we have the address? Oh, because it's in the buffer. I'm going to store the address separately. Because inside the buffer, it's going to have the bit shifted in, so eventually it might not be the address. And I guess the code that's inside could... So I suppose theoretically we don't have to give the... We don't actually have to give the address because it's already going to be in the buffer if we do it this way. And I suppose internally it could always get it out of there and ignore the first bit. I think I like it be explicit though. So for now, I'm gonna just add an address here. And that's what we will pass in. Address length is register width. We also didn't save. But it's the length of the buffer -1. Buffer was kind of doing double duty of storing the length and the address before. How does it handle devices with the same CS and MOSI MISO chained? I have no idea. I didn't know that was a thing you could do, honestly. I thought the whole point of SPI was every device needs a different CS. Well, not the whole point of SPI, I guess, but like the, I thought that was just how SPI worked, was every device has a different CS. Yeah, MOSI and MISO can connect, but then CS has to be different, and then whenever it senses that it's like, I think some devices are high and some are low, but whenever it senses that it's in its like your turn state, then that one reads and writes on MOSI and MISO, and then CS flips back to the no longer your turn state. And that is handled by SPI device, which will be used inside of the accessor when we write this. So that part gets done sort of in there automatically. But if you do actually mean multiple devices using the same CS, that I do not know. I suspect it doesn't work, probably, unless if SPI device somehow can handle that automatically as well, but I do not know if that's the case or not. So we have the address. We know the length is going to be, I guess, the length of buffer -1. I mean, realistically, we could be just passing in the buffer if we really wanted to, right? Because the address is already in there, and the length is already in there. I really like being a bit more explicit, personally, though, if I'm honest. So I think we just do a buffer. We just do it this way. So we explicitly have an address, a length, and a buffer. And then this would mean, like, even if you didn't happen to keep the address and the length and everything correct in your buffer, the rest of this could still work, which I think is good. We'll see. I don't know. Maybe we'll want to change it. So this would just read. And then inside of here, in fact, is where this is going to be. inside of here, though. Need to... Let's still get the SPI device. So the device, I think this is going to be a bus. Well, this is going to be a SPI device. And then this is going to be like that. This function needs to be in here. Where did that go? So I took it out. Function needs to be in here. Then with self.spy device, it shifts in the reading bit. We write the... so actually it would not work. So like a minute ago I was saying it would work even if your buffer was not set up right. That is not actually true though, because unless if we add code inside of here that sets the address and the length. So I think I am circling back around to maybe this should just take the buffer. If that ends up being terrible for some reason, but this just takes the buffer. This is just buffer, and that is buffer. Yeah. So this would not return either. But that's fine because this is already not expecting, like this is already expecting to pull the data out of buffer, so I think that's fine. This is a real thing. Let me pull this over to, let me pull this over to here. Which pin is CS here? Is SS the same as CS? And if so, is it just always tied to ground? They're all tied down, but they could be attached to a singular CS. I don't know. Do you know of a device that does that? Like, is there an Adafruit breakout that's like that? I don't recall running across that before, but I will say I really only been looking into the breakouts and the drivers and stuff in earnest more recently, so it's like a thing I could have easily just run across and not really realized or remembered. But I don't have any conscious recollection of any device that's like that. If there is one that is like on an Adafruit breakout, that'll be the easiest way to try to support it, is because I could get a couple of those and try it. But I would say the short answer is, like, I don't think this will work with it. The only way that it would actually work with it, I think, currently would be if So I guess honestly, this is the place to start. Is does it currently work with SPI device or not on a device that's like that? If a device that's like that currently cannot work with SPI device, then I don't think there's anything that we could do inside of either of these layers here or the driver layer, which is not open here, but is another layer involved, to make it work. It would, if it doesn't work with SPI device just all the way up there without the rest of register and everything built on, you know, on top, below, depends how you're thinking about it, but if it can work here, then it should be able to be filtered down to the other layers. But I don't know the specifics of like whether or not it actually can work there or how it does do it if it can, and or how we're going to bring it down to here if it can as well. That is interesting though. I definitely did not know there were devices like that, I don't think. Well, no, the buffer definitely should not be in here, I don't think. Buffer should stay in there. This would basically just be like that. Kind of cool. And then this would be object.register.accessor.write register. So this one will need what? I mean, it also kind of just needs... I mean, it also kind of just needs the buffer, doesn't it, right? Because it's going to get... I mean, the buffer's already going to have the address. We're going to shift in the bit correctly. We're going to tell it that we're going to write. We're going to presumably put the value of value. If, oh, okay, yeah. So this is basically, this whole thing is putting the value of value, which is true or false, right? So 0 or 1, it's putting that into index 1. In our case, it's like self.byte, but we know it's index 1. Index 0 is the address, index 1 is the data. So it's putting this single bit into there in the location where it belongs. And it will be putting it as a 1 if this is true and putting it as a 0 if that's false. Any API slave will work this way. The master wire only need to be set up for it. But how do they negotiate? Like, don't they all just talk over each other? What would stop them from talking over each other? I'm confused about that. I thought that was like... They're set up for individuals. Okay. I think my short answer would be this probably will not support it then. If it's not the way the Adafruit breakouts are made. Because, I mean, it will be the Adafruit library, so its primary purpose is to support the Adafruit breakouts. If there are any that are like that, that's the best way to try to get support added for it. Through not over. They talk through each other, not talk over each other. But don't, like, how can the main device... They would all try to talk at the same time. Is this only for one way? Is this like only when the main device is sending messages out to the breakouts? Because then it's like one to many, and it doesn't matter as much. Like, we could send the same message to many all at the same time, and it doesn't matter. But if those breakouts, like if it's sensors, for instance, a temperature sensor or whatever, right? They're all gonna try to send data back at the same time, aren't they? And then how could the main device ever know what to make of the data that came in? Because it will just be a mishmash of all of them tried to write at the same time, won't they? Or do they have some timing built into it or something? Master writes 3 bytes and reads 3 bytes coming back. And so each of the breakout devices would only affect one of the 3 bytes, essentially? Do they have to know where they're at in the chain? So like breakout number 2 has to know that it's in position number 2. Breakout number 3 has to know that it's in position number 3. Somehow with like jumpers or some kind of like telling it to that somehow, the configuration. Using multiple bytes makes more sense. I was not really thinking of that. Kind of like neopixels in a way. Each one just does its own chunk and then passes the rest along. Only the master knows where they are in the chain. So then how does the second one be sure to only update? Well, in any case, I'll have to go look at I'll have to go find a spec for it somewhere. How would the second one know to update the second byte somehow, though, only? Or whatever, right? Maybe it's not a full byte, but... Okay, so we... Well... I don't think we need byte here. Well, I guess we do. Yeah. We have to have byte because technically, I guess this could be a register width of more than 1, but we're still trying to get a single bit out of it, which would be a bit awkward. But not the end of the world, I guess. And we do need to handle it. So this has to pass the buffer, which is going to have the address in it. It needs to definitely pass which byte within the register we're trying to write and the value we're trying to write to it, which is going to be on off. And actually, we need to know the bit mask as well, because we need to know which bit we are writing into, because we are writing a single bit. But the problem with that is we want write register to work for multiple bits too, so we don't want to be passing a bit mask. So we need to get our bit into value. We need to... How do we want to do this? So we need to... So some of this needs to be back up here, actually. Like this part needs to be in here and not in here, because this is specific to a single bit, and in here you should theoretically be able to read more than 1 bit, like a full byte or whatever. They're just shift registers, they're in series. Registers, they're in series. Yeah, I mean, the short answer is I do not know. It probably, like, my guess, my gut instinct is that it probably doesn't work, but I do not know. It mostly depends on how SPI device, like inside the existing bus device, architecture, like how that handles it would be the crux for sure. So we have to copy instead of cut. To do this before we write, and then the question is going to be like, should we bother? Like, we're kind of back in the same situation again, right? Like, should we just write buffer, and that's going to write to the address that's in the 0 index, and it's going to write all the data that's in the 1 to n index. In our case, we know there's just one, and we know that that one has shifted into it the value of our bit. Yeah, I think so. And then like this, we need to come over here. Don't worry about it. Yeah, I mean, it's an interesting question for sure. Totally did not even know devices were like that out there. It's fascinating how many different ways some of these protocols get used. Self. I do appreciate the question. Okay, so it will not be buffer. This will be buffer from here. This we don't have because it already got done. So we basically just do these ones. So we write the address. Why do we have to read? What do we have to read after we write the address? Sure. It's going to read into the buffer. And then it shifts to 0 again, which is interesting. Maybe it just always expects us to do a read, but we don't do a read after this one. Let me pull up the EMP datasheet again. It's got those like diagrams that show transactions. We can see if it had anything. We're on SPI read. Or, I mean SPI write, I should say. We should maybe test without this. This feels like it doesn't necessarily need to be there, but I'm not sure. I'm going to leave it for now because it was in the other one, which was working, so maybe it needs to be. I mean, it's not sending anything back. Like, we wrote the address here, and then immediately it seems like it's expecting data. It didn't, like, try to send anything back after the address, so... yeah. Sure why that's doing that. Getting the address back again, maybe? Oh, no, it's not really getting the address. Oh, because. Right, I understand now. Yeah. Yeah, we need to do it out. We need to do it somewhere else, actually. So what this is for is because the code I should have probably started with the other one. I started with bit because it seems simpler. I guess it is simpler in some ways, but yeah, and actually the other one would have had the same problem. So yeah, I think starting here is still making sense. But basically, we don't want to clobber the rest of everything in the register. We want to, yeah, which actually that's going to wreck the way we did this, in fact, as well. Well, but that's fine. We just need to do this out here. Okay, so basically, we need to go and say, register data. Well, it doesn't get returned, though. So we just need to read first. So yeah, I haven't ever actually spit it out. Sorry. The reason we're reading here is because we need to get all the rest of whatever's in that register. Then we need to put in this case, the single bit that we care about, the single bit that we're actually writing. Then we need to write it back. So we want all the data that was there along with our change, which is that single bit there. So we need to read first. So we go accessor.readRegister on the buffer, which will have the address and everything all set. Then we shift in or whatever the value bit into that index number 1, which we just read the value of here. So we update the single bit we care about, then we write it back to there. Similar to the way NeoPixels work, but with feedback. Interesting, okay. I was thinking it kind of felt like that, where it was like in a line, each one sort of has its own chunk of data and pulls it off and does something with it and then passes the rest. Okay. So then this is gone, and this will not need to do this part. That was only done because of the way that it was shifting that bit in before. One downside, if it is actually a downside, I'm not actually sure, but I assume maybe it has a performance impact. One difference, at the very least, is that with the new way, we're calling read register and write register, and each of those are using their own context on the SPI device. Whereas before we had a single context and we made multiple transactions. I don't know if that's the correct term or not, but we opened the channel once, we conversed within it multiple times, and then we close it at the end. Here we open and close it. We open and close it. But I think that's fine for now. Because the only other thing that we could do would be we would have to we'd have to be passing all the rest of that stuff into here, right? We'd have to be passing in the byte and the bit mask. We'd have to be doing this inside of here. And I don't think that makes as much sense. We'll try it this way. We'll see what it, see if it's like realistically a problem or not. Okay, so maybe this would work. We have a register bit, RW bit. Well, we're gonna have to make the right. We're gonna have to make the multi-bit one actually before we can really test it. The only code I have to test it with is the BMP driver, and the BMP driver needs both single and multi-bits. So we basically have to do a lot of this again. I already have that. So one question is, do we start from the new one that we just wrote, or do we start from, well, like before I started with SPI bit? I start with SPI bits. Yeah, we should start with this because there's a lot more stuff going on. Okay. Yeah, we'll do while I'm here is remove the duplicate copyright. Okay, so we'll basically be doing more or less the same thing. This won't be in here anymore. This one, so I can reference it. So init should be basically the same. We do all that stuff. We put it all on self. And then here is where we start getting different. So inside of here, okay. So basically we would keep all the second half of this because this is getting the specific values we care about out of the data we got from the register, because everything we get from the register is going to be in presumably like a full bytes essentially, but we could be wanting only 3 bits out of that or 4 bits or whatever. So this, sorry, I don't know how loud that was. Hopefully that wasn't too loud. Bonked the microphone. So this is going to be getting however many bits we care about out of the data we read. This is doing the actual reading. And so here we could be doing kind of a similar thing. Wait a minute, though. Register accessor. Oh, okay. Yeah. Yes, for a second I was like, did I not do one of these for the other value? But I totally did. Okay. So writing, it shifts in a 0, and reading, it shifts in a 1. Yeah. Okay. So for getting here, so that's shifting in a 1, which will happen inside of there, of course. I don't know if we ended up needing that sleep there. I think at some point I was like trying to solve a problem, and I thought adding sleeps in random spot might help. I don't think it ended up being the solution, but I don't think I ended up taking them out. So we'll see if it causes us trouble. But I think here it's going to be self.register. Wait, not self. Object? Object.register accessor. Not too loud, no ringing in the ears, no pain. Nice. Register accessor dot read register. I don't know why we decided to pass another thing, but thank you for that. We don't need that. Right, yeah, we just passed the buffer. I wish that they would be, so this has like, you know, fancy code completion or whatever with some kind of language model. I wish they would feed the context of the open files. They like try to feed the context of the project. And my project, I think, is weird. It's got a lot of stuff that's not really part of what I'm actively working on, which again, that part's on me. That's my problem. But if they would give it the context of the files that are open specifically, then it would presumably find read register and notice that it only takes one thing. Maybe it wouldn't though. Maybe it's like asking a little much for it to go from generic object to a thing called register accessor to assuming that it's going to be this. It's a bit far, I guess. In any case, that's going to read, that's going to put it in buffer, and then this is going to basically get the data out of buffer index 1 or more. 1 to n. Right, so that should just do all that stuff like normal. This we basically get rid of. And then here, for set. So value, shift the value into the right spot. Interesting. Okay, we'll just leave value. So we need to kind of break down what it's doing here. So we are going to be, in essence, doing the same thing where we want to read the data that's in that register first. Then we want to put the new data that we're trying to put into it, into a byte. You know, maybe we're only putting, again, like 3 bits or 4 bits or whatever. We're going to put those into that byte. Then we're going to turn around and write the byte back. And so I think... Okay. So this, I think, is taking maybe, I don't know if maybe these two belong a little more together logically. But this is basically getting the register, the value from the register out of the buffer, putting it into here, which is then going to get updated with the value we want to write, which is then going to get put back into the buffer, which is finally going to get written. So we are going to go here. No more of these. Instead, object.register accessor. Right, register, and those are not correct things at all, but it will instead be self.buffer by itself. So that's going to get the data, put it into buffer index 1. We know because we're at least thinking about single width ones. The rest of this code should make it work for multi-width ones as well. I think. Yeah, well, we'll find out. We'll find out if the multi-byte ones are working or not, because the actual data, like temperature data, pressure data, those are in 3 registers. I think it should just work. I hope it will. Hope it will just work. So it goes RO bits and then this implementation is weird. It goes number of bits, it goes register address, lowest bit, and then it goes register width. Okay. Yeah, so we'll definitely find out if it doesn't work. Hoping, I mean, I'm clear to me what will make it work, but will make it work? Length, because this is doing length of buffer here. Yeah, I don't know. I'm not 100% sure what makes it work, but I think that something makes it work. Okay, so that's going to read. That's going to get the data out of buffer index, 1 to n, put it in there. That is going to write the new value into it. This is going to put register back into buffer I to n. Yeah, buffer I to n. So like, again, for us, it's like mostly just 1. It'll just be index 1. But for those, well, temperature and, well, those are read-only in any case. So truthfully, we won't actually be able to test this path. I wonder if I could find a breakout where it writes a register that's multiple bytes. If anyone happens to know offhand of a Adafruit breakout that has a device on it that has a multi-byte writing thing, maybe NVM breakout, that should be right. So you can just write arbitrary data, I think, like that. Maybe that's the way to look for. Okay. I don't know if one will do SPI or not, though. But so the code should basically be the same, I think, for I2C. Cross that bridge when we get to it. Okay. Putting all this back in the buffer, and then here we don't need to do this anymore. And instead we just go again and go register accessor, write the buffer. Then this, I mean, I suppose I could write right, but it's like calling write register and passing the buffer. I feel like it comments itself, basically. Yeah. Maybe that is everything we need to work. I'll see. So let's save this. Look again at what Scott said, or if I note this down. So, would we want to... I think we would want to keep the... So the goal is to have basically one of these. So right now, in my most recent attempt, there's actually two, right? There's like BMP5X SPI, there's BMP5X I2C. There's a unified one which has most of the code in it. The new one is going to be a unified one, but what it needs to do is inside of a NIT, it needs to set up the bus device. So either SPI device or I2C device, and then it needs to set up the register accessor, which it will store on self.register accessor, which the bit and bits class will then use. I think I want to... not actually a super great place to start from, is there? This might be the best place to start from. Yeah, I think let's start from here. This combo for now. So one thing that's going to be weird is the constructor. I'm going to start... make these into keywords and make them none by default. It changes the API slightly for SPI because you need to say SPI equals your bus and CS equals your pin, instead of being able to just pass them as SPI and CS without the equals, without using keywords. You won't be able to do that. And I could maybe see a world, we kind of talked about maybe passing in the device, actually. But that would be a bigger change for the driver API, because today the driver API, you pass in the bus and the pin for SPI, and you pass in the bus and the address for I2C. But I think first draft, at least, let's keep that part the same. So this would be none. I'm going to go ahead and use not one long line. And then what we'll do is... we don't actually need to keep SPI device on self here, but why are we one indentation off? Am I one indentation off? Hmm. Okay, I don't know. That was weird. If SPI is not none and yes is not none, do this. Resolve reference. Reference? I don't think it's actually unresolved. I think that's just being silly. Just being silly. And then what we would do is we have a SPI device, which is what we pass into this. So we would then go self.register accessor equals a SPI register accessor. We would pass in that SPI device there. Need to import this from Adafruit register. Adafruit register dot register accessor import SPI register accessor. And then for these, it would be, what did I call it? So register bit. Why it's not? Oh. Okay, there we go. And then, yeah, we do need this, even though it's figuring it out right now, but that's fine. And then we could say elif. Yeah, the address actually should not be none. That should be the default address, which is actually this, as the name suggests. So we only need to check I2C. So L if I2C is not none, then we're gonna do kind of the same sort of stuff here. Oh. Honestly, yeah, maybe we should just do the import that way. Oh, I know what the problem was. I had SPI device equals, and then it was like you're setting this to itself. It was mirroring the name of the imported thing. That's what the problem was. Yeah. Which, yeah, this is totally what we want to do, because I do want variables called these, I think, for now. I guess we gotta add instance or something, but it's like... so I'll do this, but we obviously don't have it existing yet. So it won't actually do anything, but... okay. That's going to do that. It's going to do this. So the here will be totally different. Combo import BMP5XX. BMP5XX. And then like I was saying before, these are keywords now. We have to explicitly say them. For I2C, you could actually skip them since they happen to be the first two, but SPI can't. Actually, I'm not 100% sure if that's true. I think that's true, but could be wrong. See if that works. I don't even know if I have... MP has no SPI device. It needs SPI device. Did it? Oh. I just forgot to take this out, right? Yeah, because we're not using it. In fact, it's gray there because it's not used. We can get rid of this. This goes back. Register. So I have a self.buffer somewhere where there shouldn't be. Yeah, here this should just be buffer. Oh, we're not passing the buffer. Okay, I think we just passed the buffer also. Three positional arguments, but only two were given. 27. Oh, yeah, we need to pass the buffer now. Duh. ID was incorrect. Made it further. Let's see what the chip ID was. Was it just like all ones or something, or was it random? You take out that sleep. All ones. We were seeing that before. I'm going to... Oops. Okay, so chip ID is the first thing we're doing, and it is a... Actually, the first thing we're doing is writing the reset. And the first thing we do after that is try to read the chip ID. We did have that sleep. They took out. Remember where it was exactly. It was in the reading. And it was after we wrote the address. Here. Thing. Did not think that would make a difference, but just in case. Totally was getting all ones before though. Remember what was going on at that point. I guess let's maybe we should have a debug or something. Turn these on and off. I'm gonna basically put a bunch of prints back, see if anything interesting. Oh. I put a bunch of prints back, but that's not useful because I put them into a SPI bit. And I guess inside register accessor is probably the place where we should put these. Basically did it after we shifted. Value? I'm just not gonna do value. Value's in the buffer already. Okay, so this had old register, new register, but that's actually that part is out there somewhere. Okay, so yeah, actually the deal is that we don't really have a before read into in here because that happens outside of here now. So this should just be RW bits. Actually not even RW bits anymore. It's write register. It's accessor write after, well, before. Processor read. Okay, so it should be. Why do we end up here twice? That's well, well, How do we? How do we end up there twice? So we set command. Setting command does this. Oh. Oh. Somebody has put write instead of read here. Yeah, I mean, we totally need to read. Chip ID was in. Didn't actually change anything. Actually change anything? Did not change anything. Okay. So now we read before, we read after, and in our case, we are reading the command register, which defaults to empty when you read it. All zeros. So we get zeros out. We then gonna put the command we want to do, which is the reset command. We should have written that. And we could validate, let's make sure that's 182 E6. I could just see without going to it. Yeah, okay, so B6 is that. Did I... And so... Here we are reading. Means we did have to shift it to 1 in the highest bit. And then here we're writing, so we should have shifted a 0. It won't print the 0 here, but we should only have 7 digits. So 1, 1, 1, 0, there's 4 there, and then there's 3 ones. There's a silent 0 there, a hidden 0, indicating that we're gonna write. This is the value that we're gonna write. Then we are reading again. So we put a 1 back in the high bit there. We're reading register index 1 because that is the chip ID register. So before we read, we have no data. And then after we read, we have all ones. So one question maybe is, I mean, read into, that is going to put data in the buffer, which we then immediately print. Hmm. Remember back, I swear I was getting this before at one point. We were getting all ones. I think I was not. I think when I was getting all ones, it was either I was not shifting in the leading bit correctly, or the read write command, or it might have been because we had originally, when I very first started working on this had end 2 instead of end 1, so it was actually writing 2 bytes. Neither of those are happening anymore. And oh, wait. Okay, post bit. What is this? Expected type int got type instead. This is SPI bits. One has the same problem though. Instance attribute lowest bit type. Why does it think it's a type? It's because it's not typed here. The type got into. Why does it think lowest bit should be type? Necessarily. Okay. I mean, it's a number. But we know before we even get to here, we know from inside of here that we already have all ones. Hmm. And we know that this is modifying buffer because we are printing buffer time. And we do see, for instance, that we started on zeros, then we got all ones. I was thinking for a second, like, could it be like creating a different instance, a different list or whatever? I don't think that's actually happening. I'm a bit stumped. Um, all right, so it used to go with SPI device. Shift a 1 into buffer, which was on self before, so it didn't have to pass it in, but we do now. We printed that. We wrote the buffer, end 1. We slept. We read back into the buffer, starting at 1. We printed the buffer. This appears the same as this to my eye. And then Starting here, reg 0, order, you length of buffer -1. If not this, reversed. I in order register equals these things. And then return. Could we have put it... Maybe I should just reset. I should just totally reset. In case if I got it into a janky state earlier when we were writing instead of reading or whatever. Vice versa, maybe. Okay. Well, everything's the same. And I had accidentally put a bunch of... I put the prints back in register bits, or SPI bits, I mean. So this is printing a bunch of extra stuff. But I mean, it definitely works. In fact, we could get back up to here. You kind of see the exact same stuff, so... I have different versions of these, which is a little awkward, but... Buffer when we were reading... Restarted. Oh, that's so annoying. We had a 1. Shifted into the high bit for reading. Old register was 0. The new register... That got stored here. And this is before we wrote the data, so then we would have written that next. We then read the chip ID. So we have our 1 back here again in the top bit. But we got back this instead of all 1s. I don't know. Maybe we can't do... Maybe we can't do... different transactions? Maybe we need to wait before we do them or something. So one question is like, which one's failing, basically, right? Like, are we failing to send the reset command correctly? And then as a result of that, is the chip just in an unknown state? It didn't reset, basically, so it's in a wonky state? Or is our writing working correctly? We're sending the reset command and that is actually resetting the chip, but our reading is broken and we're reading all ones. Kind of like two places it could be broken. The only really difference I can see in the code is the way how the old one was doing one transaction, I should say. Whereas now we do have two. We have read register here, which gets the data out and puts it into register and then puts in the new data into it and then puts it back into buffer and then writes it under a different transaction. Whereas in this one, it all happened under one transaction. Okay. It doesn't really say. It doesn't really say anything about timing between transactions, really. I don't really think that will do anything. Oh. It's like, did something. But truth is, we're still back on this old one. Yeah. I don't know. I don't really know what could be different. Say I don't really spot anything that is fundamentally different in a way that I would have thought mattered. And I mean, it seems like we Well, I mean, for the case of the reset command, it doesn't really matter. I say it seems like we're reading successfully. I mean, we're reading zeros anyway. Might not know, I guess. I mean, we're not getting ones, I suppose, so that's good, but... Does chip ID say anything about... I don't think it does. Yeah, just... as default values of whatever number is for the chip ID. Doesn't say anything about, like, if you get all ones, it means this went wrong. Maybe yeah, I don't know. I'm gonna exaggerate sleep, but I still don't really think it's gonna make a difference. All right, let's go in here and that just takes a buffer. And before we wrote it, it said had this in it. We checked this, and this was the reset command. And this one would have a 0. So only 7 digits. There's a silent 0 there. And that just appears correct. And we just get SPI device and put it on self. That should mess with anything. Buffer shouldn't change, so I mean, I guess we could print it again, but it shouldn't really be any different. I don't know. I think we gotta pick it up another time, though. I feel like we're headed in the right direction. I think, like, read and write API like this, and then the bits are essentially agnostic. As far as the actual, like, implementation, it seems to be coming together. But it's just not working correctly for some reason. Yeah. We may have to, like I was talking about last week, a couple folks dropped by in the chat with pointers on using using a Raspberry Pi Pico as a logic analyzer. Maybe I need to bust that out, see if actually on the wire it's got the reset command correctly, and if on the wire it's got all ones for the chip ID or what. But I think that will be for another time. I think I'm gonna head out for now. Should be back for the usual streams next week, I think. Yeah. Deep dive on Friday afternoon. That one is at 2 p.m. Pacific, 5 p.m. Eastern, 1 p.m. No, 4 p.m. Central Time, 2 Pacific, 5 Eastern, 4 Central. Friday for deep dive on the Adafruit channel. And I should be back next week on Saturday as well, here on my channel, 10 a.m. Saturday, 10 a.m. Central on Saturdays, I usually do. Thanks for hanging out in the chat, Gordy G, C Grover from before. If y'all are still around, appreciate you watching along. Appreciate everyone else, even if you didn't talk up in the chat. That's cool too. I like lurkers too. And yeah, I will see you later. Hope you have a good rest of your day.